Welcome back, everyone. I hope you had a lovely time in the coffee break. If you could take your seats for the last session before lunch. It's lovely to see so many of you still looking bright-eyed and bushy-tailed after a couple of really intense days. And I would love to hear from you kind of the themes that you're seeing emerging over the couple of days that we've had, and how it might compare to previous years or conferences on AI in other sectors, just to kind of get a sense of like the temperature of where we are. We're seeing a whole range of opinions about AI, the ethics of things, the practicalities of things. So we're going to learn a lot from the couple of short papers that are coming up next. Each speaker will have 10 minutes, and then we'll hopefully have time for lots of Q&A together at the end. I'm going to keep things quite quick. So I'm going to invite Stephen and Sophie up to do their first paper. And let's all sit back and learn something.
Thank you. Hi, good morning. My name is Stephen Claeyssens. I'm a curator of digital collections at the KB, and we have two of those at the KB. The other one is standing over there. That's Sophie. And we are here for our paper, and I hope we get some slides. Distrusting, techno-pessimistic, and conservative. Oh, I have to do this myself. Oh, sorry. I thought there was an AI doing this. Okay. 2 years ago, the National Library of the Netherlands issued a statement on generative AI, basically saying that we do not really agree with the way commercial companies, big tech companies, creating these AIs, these large language models, are just simply scraping or crawling our content, meaning our digitized and digital collections. What we did not really expect that we could become really under fire after that. There were people, creators, illustrators, saying that we did not really respect their content enough. There was something we could call some friendly fire from Germany and the UK, saying that, pointing out that we probably do not have the legal position to block access to our materials. There was from our friends from Europeana saying, isn't this contrary to what the mission of a heritage institutions should be? So counter to the mission of publicly funded cultural heritage institutions. And there was, let's say, a long missile from the north saying that we are techno-pessimistic, distrusting, and conservative. So, how did we end up in this crossfire? Let me first, I will explain something on the background of this statement, and then Sophie will give you some of our reflections on that and how we are moving forward in this. First of all, we have to go back 2 years. In the summer of 2023, there was an article published in a Dutch national magazine. Data journalists and Utrecht Data School people had been trying to figure out by reverse engineering what kind of data had been used to train the LLMs, or the big tech LLMs, for Dutch. And this is top 10 of the data being used, and there on 9th position says dbnl.org. This is one of our websites. This is the Digital Library of Dutch Literature, where we publish novels, poetry, Dutch and Flemish, literature and linguistics, etc. But, important thing to mention here is that this is not only public domain material, there's a really substantive portion of this is also in copyright. How is that possible? For that we have to go back even further, 50 years in fact. We've heard from the Swedish National Library already, we've heard from the German National Library about legal deposit. In the Netherlands we do not have a legal deposit, we have a voluntary deposit. This was established 50 years ago. There was a lot of discussion. It ended by agreeing we won't have a legal deposit because the voluntary deposit is working as well as a legal deposit. What this also meant is that this was really the start of an ongoing dialogue and an ongoing discussion with publishers, with authors, with CMOs, collective management organizations representing those makers. So by 2010, without any legal basis, we had been able, in the same vein, to have agreements with both publishers and collective management organizations to publish what we are digitizing, which is in copyright, online, and to give access to that and give copies of that to researchers for research purposes. So, for instance, for newspapers, historical digitized newspapers, we were able to publish those up until 1995 already in 2010. Fast forward, the last agreement we have from 2024 is already giving us the opportunity, or is allowing us to publish newspapers up until 10 years ago, so with a moving wall. So for now it's 2015. Which means that, oh, and it's important, of course, to stress that in 2016, the KB said that everything that's no longer copyright protected is in public domain, should remain in public domain. So that means that anybody can do whatever they want with that. This means that we now have 2 websites where we publish huge amounts of digitized Dutch text publications, both in copyright and out of copyright. So this newspaper from 2005, last day of 2005, is online on delver.nl for everybody to use, everybody to see for free, but also being scraped or crawled.
So where do we stand now? You've just heard from Stephen how the KB's role was shaped long before the age of AI, through trust-based agreements, collaboration with publishers and CMOs, and an access model originally designed for human readers. But the balanced ecosystem, in which everyone's role was clear, is now under serious pressure because of AI. And you can see that not just in the technology itself, but very clearly in the public debate. Let me show you a picture of the campaign launched by the Dutch Authors Guild last October. It's called AI is Theft. It says, written by a human, subtitled by a human, translated by a human. So right, if AI is theft, then what does that make us? In that narrative, we become the dealers of stolen goods. And of course, it's more nuanced than that. And that's exactly why it's essential that we reflect on our position in this changing landscape. We increasingly find ourselves positioned as gatekeepers of data. Our collections are no longer only cultural heritage or research infrastructure. They've become high-value training material in the global AI economy. That creates a responsibility to represent all interests at the table: creators, publishers, researchers, and the broader audience. We remain committed to openness. We work hard to keep our services and digital collections free and not behind paywalls. And as the single source of most printed works in Dutch, we have that responsibility. But we have also become part of the Dutch publishing ecosystem ourselves, as republishers of works that are still in copyright. And it's in the interest of society as a whole that we acknowledge the rights of creators and publishers. Libraries and heritage institutions should not be pushed, even unintentionally, to act like a kind of pirate bay. And that brings us to the paradox of open. Push openness too far without supporting creators, and they will withdraw, not only from AI reuse, but from our platforms altogether. Or, as Open Future argues, open data without conditions can strengthen the very power asymmetries it was meant to counter. And to put it very bluntly, open data was never meant to help big tech consolidate a monopoly over human knowledge. So how are we proceeding? For us, the answer is not to shut things down, but to practice responsible openness, striking the delicate balance between enabling text and data mining and respecting creators' rights, privacy, and legal obligations. And that is why we are rethinking legal tools, such as the database right. Not because we want to own these collections, but because we need clear and fair conditions for reuse, stronger safeguards for privacy in modern collections. We bring publishers and creators together in stakeholder dialogues to identify shared priorities and agree on the conditions under which AI initiatives could be supported. And we are exploring technical measures that allow access without unlimited extraction. And finally, we are sharing our story in rooms like this because we believe national libraries, but all GLAM institutions for that matter, should actively rethink their position in this changing landscape. So let me end with a simple truth. As a Dutch saying goes, trust arrives on foot, but leaves on horseback. Everything the KB has built over the past decade, all the digitization projects, all the partnerships and all our services rest on that trust. Openness remains essential, but in the age of AI, it must be responsible and sustainable. So last but not least, ethical judgment must remain our compass, especially in a landscape where the law is not yet fully equipped to deal with AI. And only if we manage to preserve that trust, and if we prove that we are truly a trusted party, can we continue to fulfill our societal role. So, to be honest, we don't recognize ourselves in the adjective used to describe us. We think we are, or at least we strive to be, responsible, ethical, and forward-thinking. Thank you for your attention.
Good morning, everyone. It's wonderful to be here. It's slightly terrifying. My name is Amanda. I'm the head librarian of the marine biology branch of Stanford University Libraries. I'm here with my colleagues Claudia and Peter, who are with the library's Research Data Services Unit, and Simon couldn't be here with us today. We're going to share with you a project we've been working on to extract historical biodiversity data from structured images. And I'll start out by introducing you to the collection and sharing why I think it's important that we extract the data. And then I'll hand it off to Claudia and Peter to describe what we've been doing and how we've been doing it. So the collection materials we're sharing today were created by Ed Ricketts, who was a marine biologist based in Monterey, California. He's best known perhaps as the author of Between Pacific Tides and also The Sea of Cortez, which he co-wrote with John Steinbeck. If you're a fan of the American novelist John Steinbeck, you might be familiar with Ricketts as the inspiration for the character Doc in the novel Cannery Row and Sweet Thursday. In the marine biology world, Ed Ricketts is famous for being one of the first Western scientists to think about not just how animals are taxonomically related to each other or how they cluster based on their physical characteristics, but he thought a lot about how they exist in relation to one another and their environment. So, for example, he thought about how they're distributed in space, like these 4 species of crabs that are arranged geographically from north to south, and how these other crab species might be arranged from the deep subtidal up to the upper splash zone of the tide pools. So to feed his curiosity and provide data for his writings in Between Pacific Tides, Ricketts explored the western coast of North America, making observational trips from between 1925 and 1948. And he was an extremely meticulous observer. To document the distribution of species that he saw on these trips, he created a card system where he tracked where and when he saw all of the species along the coast. And what we have now is an extremely important and valuable baseline for historical species occurrences in these intertidal communities that he was exploring. So this benchmark is really important because in order to be able to assess patterns like changes in biodiversity in response to climate change, researchers really need observations over long time periods and wide spatial scales. But especially in marine environments, which are difficult to access, there's a gap and a shortage of observational data in these areas. So what we're working on at Hopkins Marine Station in my library is trying to extract observational data from historical records and through digitizing and transforming and making data available to our researchers with collections like the Ricketts cards. So just as one example before I pass it off of the kind of gaps we can work on filling by mobilizing historical data, I'm showing here species occurrences of the striped short crab that you can find in GBIF, which is one of the world's largest biodiversity databases. And what we see is that there are over 21,000 observations of this crab in GBIF. But if you restrict the data to just before 1950, which is the period when Ricketts was active in his work, you lose 99% of the data. So what we're working on is the idea that library collections can really help fill these observational gaps if we can extract the data accurately and make the data computationally available for researchers. So in my previous explorations with collections like this, I found that OCR and HTR really weren't sufficient for extracting structured data. And so I reached out to the Research Data Services group to see if they would help me with this. And so now I'll pass it on to Claudia, who will take it from here.
Thank you. Yeah, so we are experimenting, and Peter will talk more about this, with VLMs. This is an example for a general format of this card. They were scanned back, the front side on the top, the back side on the bottom. It's one image. The top contains general species information, and at the bottom are the observations. There are about, you can see there were 5 different voyages, so there's a total of about 1,200 cards. So it's not a huge collection. Most of the cards adhere to the system, but there are some that are exceptions. So there are sketches, there are typed up notes, and there are some photographs. So I started with figuring out a prompt of about roughly 250 lines or so. The first section of this prompt gives some context. So it's figuring out, or it's telling the model this is what the image is about, some disciplinary context, so it's about or local context also, it's a geographic context, Pacific coast, it's marine species, and then I'm describing the sort of roughly the structure of the card. I follow this with some instructions, what to do with this card. There was some, you can imagine, quite a bit of iterations actually, going back and forth how to do this best. So instructions, what to extract, how to extract it, what not to extract. And then I have a clause here, if the extracted text cannot be assigned to a specific field, then just say field undetermined. So that's why I was hoping to throw all the exceptions in. The output in JSON format, so we could process it. This was a very simple instruction. I added some specific instruction for the table at the bottom with the observations. It turned out when I tell the model, think about CSV table and then go to JSON, resulted in better extraction. So that's where that happened. And then I have to describe these funny things, these quotation marks that were used to repeat a value in the previous line, so that I added those instructions. I developed a JSON schema. Here's the top of it. I think I have here's the whole thing. So on the left-hand side, essentially, I'm coding all the species information, and on the right-hand side, there are the observations. This helps us, and Peter will talk more about this, validate this model, or the results. Here's a hypothetical example where I provide this. Here's an example of the output, the left card, and then how it is transferred into the JSON format. And one interesting observation, which is a little bit of a quibble and kind of interesting, is that it's not surprising that this model, or these models, given that they are trained on semantic similarities, that they are sort of interpreting the results. So it assigned correctly, for example, the intertitle, so lowest intertitle to the, what's this called, title horizon. So it inserted information even though it is not directly on the card. So that raises the question, what to do with this kind of interpretation.
All right, thank you, Claudia and Amanda. In the remaining time, I'll just describe a little bit of the details of the software and AI model environment that we're developing here. And a lot of this is work done by my colleague Simon Wiles, who couldn't be here. But yeah, we are definitely expecting a human to be in the loop for a lot of this work. So we're also trying to build a somewhat reusable framework that could be applied to other collections that are similar. And specifically, we think that the overall framework for the review of the results is something that's reusable. What is less reusable, it turns out, is the prompting infrastructure for superstructure, because that can change a lot based on what model you're using. But it's aspirational to some degree, but you can see some of the overall objectives for this kind of system. We want to allow rapid swapping out of different models and prompts and parameters, and also especially to facilitate repeatable evaluation of a given model and prompt. So one way we do that is just by providing an interface for reviewing the results. This is kind of a web-based version of the mock-up that Claudia just demonstrated, where it's possible to page through the card images and then see in the web interface, see what fields they were assigned to on the left. We eventually hope to augment this with a bit more information about, say, confidence levels in the transcriptions, and also what we now call visual grounding, also known as where the text actually is on the image. Because it turns out, regular OCR, that's what it does, but these vision language models are generally pretty bad at that. But as we discussed earlier this week during the IIIF and AI workshop, they're getting better. So that was our sort of manual review interface, and this is the kind of back-end review, the back-end model comparison interface, which is actually based on an open source project called PromptFoo, which a lot of groups are using these days to compare the outputs from multiple different models, and actually you can input various test cases. So obviously testing against ground truth is a particular kind of test case, but there's also much more straightforward test cases, like just does the output JSON actually validate against the schema that we've defined. So our findings so far, again, we get very different results based on which, we can get very different results based on even which inference framework we're using for the same prompt. It's also important to think about the speed of the processing and token consumption, and that's something that PromptFoo also keeps track of. And you can see our experiences so far with Gemini, Gemma 3, and Qwen 3 VL. One of the core, there are edge cases that we have to deal with. One of the other core challenges is just with anything involving VLM transcription is outputs that are subtly wrong. And here's some attempts at some steps towards reproducibility and transparency. So thank you for your attention.
Am I? One more. Okay. All right. So hi, I'm Erin Wolfe. I'm a digital initiatives librarian at the University of Kansas, and I'm going to talk for just a little bit about a rather long project that involved using AI tools to generate fairly comprehensive metadata for a large digital collection. Here's the collection in question. It's 174 reels of microfilm containing the student newspaper published at the University of Kansas from 1878 to 2017. Despite being used on a weekly basis by researchers and interested parties, there's really no metadata for it beyond sort of a broad date range by reel, which could be a few months to several years. There's a little bit of an internal database that's not frequently used at all. This is an old version of the slides. I apologize. Anyway, what you should see here is a little screenshot of it online. It's not publicly available yet, but it should be within the next couple weeks. Waiting for a couple last things to fall into place. So basically, I ran this through the workflow that I'm going to describe here. And the 174 reels translated into just under 190,000 individual pages after some image cleanup. And each of those pages was then indexed through a couple different processes that resulted in just over 1.1 million sort of content items on the page, which are things like articles and letters and all of those little, anything that's on a page, excluding some aggregated categories like classified ads and comics and things like that. And then each of those items has a title or a headline, a brief content summary, a category, which is sort of really broad, like campus news or sports or national news. Some keyword subject terms, named entities when possible, as well as a separate data set of 750,000 advertisements that is sort of similarly described. Here's a simplified version of the workflow. We actually started with the TIFF files in our online repository, which made it easy to track the metadata through the different processes because everything already had a permanent ID. A lot of the work was then done, prep work was done in that first box, which was the prompt development, the programming, which involved Python and APIs and some Kubernetes. The actual work was done in that middle box where each image was run through a couple different systems with the output going into the purple box on the end, which is the metadata. And if you can see, all of those boxes point to the pink triangle or diamond at the bottom, which is the QC. So this was really iterative, lots of quality checking and cleanup along the way until it sort of pushes out at the end with the sort of final metadata files. In selecting the right model for this, we identified these 6 criteria, which fell into 2 broad categories, which was sort of how well the model could interpret what was on a given page, whether that was textual or visual, and then how well it could format it to meet the requests that we had in a few different ways. Here's a high-level look at the models tested. The blue line represents that visual processing, and the brown line represents the output formatting. On the left side are open source models with some commercial models on the right side. You can see that 2 sort of scored highest in both categories. The one on the far right there is the Claude 4 Sonnet model, which did a really good job, but my early testing estimated it would cost about $10,000 to run an API cost, which we didn't want to do. And the one sort of towards the middle there cost $0, so the open source model. So the GLM 4.5V was the winner. It's 108 billion parameters, but those letters sort of at the end of the model name mean that it's a quantized version, so a sort of compressed version. So it's only using, I think, 8 to 10,000 at a given time. So a lot of time was spent on the prompt development. This is just a snippet. There was actually 3 different prompts for 3 different AI tasks. The longest was about just under 1,000 words. But sort of the technique that we sort of came to was to use things like XML tags to wrap different parts of the prompt and use bullet points and capital letters and in-text examples and things to sort of guide how it's going. So after with that sort of infrastructure in place, each page was then run through layout parser, which is, I don't know when, it's been around for a while, but this identifies, it's very visual, and it identifies sort of content blocks on the page. Using the newspaper navigator model, it identified sort of headlines, which are those yellow boxes, and you can see the different colors. For a red, it identifies as a photograph, and mixed content, or sorry, advertisements in the blue. You might notice it's just focusing on the headlines, not full article, because it's sort of, again, it's very visually based. And so on the left, you can see them side by side using the layout parser and then running it through the GLM model. The layout parser identified 28 article headlines. It doesn't do OCR by default. You have to kind of add that in if you wanted to as a separate step in the pipeline, whereas the GLM-V identified 47 articles and was able to extract that metadata that I described earlier. I left those gray boxes in on the bottom corner there to show that there was a few things it didn't identify, so it's not a perfect system by any means. But it did, I mean, I think really pretty good. Okay, there's a slide missing. I'm going to back up just a minute. So some of the things it did well and didn't do well, I'm happy to talk about this more, and I'll try to upload my updated slides online so you can see. But So the GLM, it did not actually do those bounding boxes. I went into Photoshop and added those for demonstration purposes. It did a really good job of sort of content detection and evaluation, but it did a really bad job of exact OCR summary. And there were some other things around that. So having run all of those pages through these processes, we have all this metadata, so what to do with it all. In our repository, each page gets its own mods record that has sort of an aggregated, sort of a concatenated list of the titles and the most frequently used subjects. Same with the month level, but with the most frequently covered topics of different types. Each page has sort of a sidecar plain text file, which is shown in the image there, that has that page level metadata at the top, and then each item, content item on the page would have a sort of little block of text with all of the metadata. All of the individual data sets will be available as CSVs for programmatic research or future reprocessing if we wanted to, as well as the full IIIF collection that makes use of the layout parser bounding boxes in combination with the GLM extracted metadata. That's a little bit future planning there. To let the user know that AI had been used, we've got this statement that we've come up with that's included in every mods record. It's displayed on every page. It's included with all of the metadata. And it basically says that AI has been used and it may be incomplete, misleading, or inaccurate. And then additionally, in the record origin field, we track the specific model that was used. I'm not sure where I'm at on time, but thank you. I included this, and so it may be hard to see. There's the repository that has the code and the prompts. I liked these quotes because this took a long time, and some of the steps you just couldn't speed up. The clip from the newspaper is actually talking about first and second year students at the university, but I thought it was fun to apply to working with AI as well. So that's all for now.
And hi, I'm Richard Naples from the Smithsonian Libraries.
Yeah, I'm Mike Trizna from the Smithsonian Office of Digital and Innovation.
And today we're talking about Wildflowers as benchmarks, our creation of a LAM-Specific LLM evaluation tool. And I will try and be quick. So Smithsonian, 157 million objects in 21 museums, libraries and archives, research centers, a zoo, the whole shebang. As a, an institution, we are also grappling with AI, but we've recently put together a draft of policy to actually start, implementing and using AI. But one thing remains, and that's the balancing the needs for this innovation with, concerns about authority, trust, making sure that people, that we do a good job with this. So, we have this policy with an emphasis on training and evaluation, or testing and evaluation, but, we still have the problem of which models to select. And so, there are benchmarks out there, but oftentimes we don't know if they're a good fit for us. There's existing ones. There's many, benchmark sites where you can see how the different models rate. But a lot of those are very general task or general intelligence kind of activities. And we have very specific needs, domain-specific needs, cultural sensitivity, et cetera, et cetera. So we have a goal with this to create more specialized evaluation benchmarks using materials from libraries, archives, and museums so that we could start getting a way to evaluate. And specifically, our project was to see if we could evaluate or create a method and a data set for us to evaluate these things. And, I do want to say, we had a kind of secondary goal, two secondary goals in this. One was to also use this project in order to start educating some of our colleagues on, artificial intelligence, the need, how to go about evaluating and how to create their own benchmarks and get them involved in the process. And we also, wanted to encourage everybody else to start making their own benchmarks and get this out there so that other people can use them. And so the inspiration for this came from a data journalist and associate professor, Derek Willis, who did a project where he took 1,000 political emails in the United States, and all of them had to have a kind of an indication of where the funding came from. And so he took 1,000 of these and created a data set of that and ran it through different models to see how well they would do picking that information out. And so we thought maybe we could do something like that. And in order to do that, we picked somebody we really like, Mary Fox Walcott. And she was sometimes referred to as the Audubon of botany, maybe just at the Smithsonian, I don't know. But she was a naturalist and illustrator who late in life married the secretary of the Smithsonian, Charles Doolittle Walcott, and would travel with him as he did his paleontology trips out west to the Rockies, and would do illustrations of the watercolors of the wildflowers. Sorry. And so they kind of had these and put them together as a fundraiser, North American Wildflowers, this book that has 400 plates as a fundraiser, basically. And we really like Mary Fox Walcott here at the Smithsonian because her material is throughout the Smithsonian and offers us lots of different ways to kind of do projects and figure things out. Her collections, the actual specimens are in the herbarium, her papers are in the archives, her books are in the libraries, the actual watercolors are in the American Art Museum. So we really like her. And the book we used has 400 botanical plates. And each of those, and you can see like the beautiful one in the middle, and on the left here, you'll see that there's just a short description where she goes through and explains what the flower is, what it looks like sometimes, where it grows, and specifically like where the specimen was found and at what elevation sometimes. But we felt it was a really nice, short, brief example of the kind of data we all encounter and might need to use. So we thought this would make a good example to work with. The other nice thing, this is in the Biodiversity Heritage Library, and they've done optical character recognition, but it's uncorrected, and so we had to clean that up. So I'll turn it over to Mike.
Okay. So yeah, another important part to point out is that for each one of these pieces of text, it's written in a narrative structure, so each one has the same types of information in there, and we could spot them, a human could spot them, but we wanted to see if a machine could, and this is kind of a task that LLMs are really well suited for. So we first collected all the data, we pulled down the page images and the metadata from the BHL, we cleaned that up. Richard did a ton of work going through manually, comparing the page image and the uncorrected OCR that was done by Tesseract, I believe, originally. So we had ground truth text there. And then the annotation part. So we put that all together into a Power App interface to allow others to annotate it, and we'll be talking about that next. And then after that, we evaluated how well the LLMs did, just some initial evaluations. We packaged this into what we called a knowledge extraction tagathon. It was a workshop organized at in the Smithsonian Libraries. Richard invited, I believe, the entire Smithsonian Libraries and Archives team. We had a few people showed up in person. A lot of people showed up online. We brought out the actual books with the plates to look through. And then we actually started out with an overview, kind of a lot of these slides here, talking about the process, why it's important. We obviously didn't have any results or anything or pictures like this, but we went through the annotation process and using that Power App interface there. So you might be able to see it's super small, but you see the text, it's actually like the corrected OCR text, so you can copy paste, and then all of the different fields that we were looking for. So this is, there were so many different fields that we could have kind of pulled from there. We came down to these 8 here, put it into this prompt that included the field name, the definition, and then some instructions about like how to handle certain things that, again, we iterated a bit on this to make sure that we had enough information for both our expert annotators as well as the LLMs. Yeah, and then we got all of our ground truth annotation. We ran it the same thing against LLMs, and then it was time to like evaluate these. And it seems like a pretty easy problem. Like, did it get the same text on one or the other? And a lot of these, there had to be some normalization done. So in this example here, where we're looking for the geographic range of this one species, I guess the ground truth was included the from in the beginning, did not include it. The expert annotator did not include it. So is that right? Is that wrong? Can you? We ended up coding in a little bit of wiggle room in there. And this, I think, alone is like a good takeaway that to show the annotators right away. This is what the LLM thought. It would be counted as wrong because it had one word wrong. So that's a good takeaway. So just to show some preliminary results, we ran this through some proprietary models as well as open source models. This gets to a lot of the discussion earlier. We chose Gemini just because it has like 3 clean levels to compare against. So I guess there's 2 different dimensions that we wanted to test on that, which one does the best, but also like what is the smallest and cheapest model that we can get away with. That's also really important to consider. So the high level numbers here show that this, the kind of like middle ground, cheaper version still does pretty decently, and then you can like really get into the individual fields there to see how it performed on different fields or tripped up. And then for the open weight model, we went with Qwen 3. Again, we could have chosen so many, but this one we chose just because it's got 6 clear weight levels that we could kind of like look at a gradient across them. And it would be really nice if we could use that really small one, but it doesn't seem like it did well enough. We'd have to really get into the individual results to see where it did poorly specifically to take considerations, but all of the data's there. That's why the beauty of a benchmark data says we can test out different variations. We can test out quantization of models to see if it makes a difference, or the prompt, and keep on iterating. All right, so yeah, the benefits. Again, we can keep on iterating on this. It'll be there for current and future models. There's a new best model that comes out every single week, so we can actually see like how does it actually do on this data set. And then, like Richard said, we want this to be like the method for this to be out there for people to try and do on their own. Yeah, and then I mentioned that the workshop was set up as like an educational experience as well as like a hands-on activity. So we can package that up into a carpentry style lesson that teaches AI evaluation. We can even maybe do a few of these exact annotations and then pull out the rest of the data set like a pre-baked oven in a cooking show or something like that. And then also we need to do a better interface like the Smithsonian Transcription Center. And then we've got code, data set coming soon. Once we have a data set card, we really want to finalize that before publishing. But many thanks to all of our annotators, and I'm getting the call-off music.
Good afternoon. Another National Library representative here, so I'm pleased to be here. So my name is Swain. I'm the Director of the Digitalisation Projects section at the National Library of Australia. And before I begin, I would like to acknowledge I live and work on the traditional lands of the Ngunnawal and Ngambri peoples in Canberra, Australia, and I pay my respects to First Nations peoples here with us today. And I have it on good authority, it's 34 degrees at the moment back home. So here we go. All right, so yes, as I say, very grateful for the opportunity to be here today to showcase how the National Library of Australia is enabling its audiences to more meaningfully discover and engage with its digitised manuscript collections in Trove through handwritten text recognition. The project I'll discuss today supports a long-held ambition for the National Library to unlock the value of its manuscript collections, and the project design and delivery has been very much developed on the principles of access and engagement. But first, something about Trove. So before I take you through the project and our use of HTR, to provide some context around Trove. So I know many of you here today will be familiar with Trove, and there perhaps may be sort of a sprinkling of users, but just for context, Trove is big, particularly by Australian standards. It's a vast collection of Australian stories and culture in one consolidated online platform, and it's growing every day. So it includes born digital and digitised content from GLAM, research and community organisations across Australia, both large and small. It preserves and delivers access to a range of diverse digital collections and holdings, and supports discovery of and access to physical collection holdings across the country through hosting collection metadata. Trove has an active and engaged user base with consistently high visitation rates, including from regional Australia. For many years, Trove users, or voluntroves, as they are affectionately known, have also been able to enhance or text correct OCR transcriptions of our digitised newspaper collections. So why have we undertaken this project? And I'm conscious I'm sort of preaching to the converted here, but just to give a brief summary. Firstly, it recognises the immense research value that manuscript collections provide as primary archival sources, which is more important today than ever. We have carefully preserved and cared for these collections over time, and they can be trusted to be true and accurate records. Secondly, we wanted to deliver our digitised manuscripts collections in a way that our users could more easily access and engage with, no matter their location, area of interest or research experience. This includes supporting our users to enhance transcriptions of manuscript collections through text corrections themselves. And of course, we wanted to enable search and discovery at scale within and across collection formats through keyword searching. So in short, the driver has been to present these collections in a way that better supports their research potential and to complement existing search and discovery options for other collections in Trove. And here is the problem we were addressing through the project. So we had a long-standing ability to make our digitised newspapers text searchable in Trove, which continues to deliver great value, so that's a good thing. But before this project, there was no way to provide a similar experience for our archival collections. And we very much knew that this was a big limitation for search and discovery. And we needed to address this problem within Trove infrastructure and budget. So obviously some constraints around how we would tackle the problem. So as I've touched on, the solution was HTR for Trove to enable editable and searchable automated transcriptions for our manuscript collections. So we wanted to apply this technology to our legacy content first, which had built up through our digitisation program over a number of years, but to also have the capacity to apply it into newly digitised content as part of a sort of a current workflow. And we wanted to leverage what we already had, with the aim to deliver the project and eventual program of work through Trove in our digitisation program. This was both a pragmatic decision and one that directly aligned with the collection engagement focus of what we were trying to achieve. Our newspaper digitisation and OCR program, delivered with the support of our digitisation panel, also provided a solid basis for us to try and emulate a similar approach for HTR. So this ambition was also noted, outlined in our digitisation strategy and the engagement principle of that strategy. It's also worth noting the project came at a time after increasing investment, and maturity in the library's digitisation program, resulting in year-on-year increases in the scope and volume of manuscript content being digitised and delivered through Trove. So both the need and opportunity to come up with a suitable solution was greater than ever before. The official project to deliver HTR for Trove was quite fast and was completed within 12 months. through our digitisation team. I don't want to say it was easy though, so there was a long lead time prior to that, which I'll touch on. So the basis was founded in long-term senior support and ambition to open up our manuscript collections. Improvements within our Trove ecosystem over many years had also helped to enable this innovation. This includes an important change within our digitisation management system to automate and streamline the workflow for sending and receiving digitised content externally. A very practical change, but one which has had a big impact, particularly with over 10 million legacy digitised manuscript pages the library holds. Trove's full text indexing has also provided the basis for enabling our HTR content to be searchable in Trove. This is another example of leveraging what we had to deliver this innovation. This approach has also meant that while our solution has been enabled by technology and a measured application of AI, it has not been the driver. We designed the project to deliver maximum impact for our audiences so they can engage with our manuscript collections in Trove in a sustainable way and within our finite resourcing envelope. The project also came at a time where the National Library's approach to AI was in its early stages. It has helped shape our thinking about the benefits of using AI to support our goals of enhancing collection access while ensuring we uphold our vital stewardship role. As an organisation, we've also had success in developing other solutions to automatically transcribe interviews from our oral history collection, transcribing all 30,000 interviews in the collection. But that's a story for another day. And here is the overall workflow for applying HTR to our digitised manuscript collections. So the first 3 steps cover the process to digitise, select, batch, and provide content to our external providers. The HTR process is undertaken externally to convert handwritten and typed manuscript collections material into digital text. We receive METs and Alto files in return, which provides the overall structure and page-level descriptions of the HTR content based on the specific digitised image. This content is then validated and ingested into our digital library collection and is live on Trove at that point. The final but crucial part of the process is for the content to be indexed through our internal harvester application for Trove. At this point, the transcription is in our digital library collection system, live in Trove, and importantly is also discoverable, searchable, and editable. And that's editable by our users that engage with the collection content. So here's just a quick view of the progress we've made so far in applying transcriptions to our legacy digitised manuscript collections using HTR and OCR processes. Importantly, we can now apply these same processes to our newly digitised manuscript collections. And you can see we started in December 2023 with a pilot just to see whether this was feasible, working with our providers and internally with colleagues in our digital branch as well. And then we've seen that the progress has steadily increased over time, which we're quite pleased about. So here are some of the results as you see them in Trove. So the digitised image is on the right-hand side, my right-hand side, and the transcription is on the left. So you can see that together, and the keyword search within the content is highlighted. So that's just to sort of see, and that's obviously you can navigate through that text, and that will actually highlight within the digitised image. So prior to this work, there was no way for us to provide a transcription for this material, including for both handwritten manuscripts and typed manuscripts as shown here. And in turn, there was no way for our users to obviously engage with that content or make text corrections. So this first example is from the papers of Dame Enid Lyons. Lyons was the first woman to be elected to the Australian House of Representatives and to serve in the federal cabinet. On her election in 1943, she received many messages of congratulations, including this telegram from Nancy Astor, the first woman to take her seat in the UK's House of Commons. This next example follows the same structure, with the digitised page on the right and the transcription on the left. This example is a handwritten letter from Andrew Banjo Patterson. Patterson was an Australian bush poet, journalist, and author, considered one of the greatest writers of Australia's colonial period. And you just have to take my word for it on that. He wrote the lyrics to Waltzing Matilda, and his image appears on the Australian $10 note. In this 1905 letter, Patterson recounts a trip in an early motor car which caused an accident when it spooked a horse. That accident was also reported in the newspaper at the time, which is also available within Trove, within our digitised Trove newspaper collection. The final example is that of Freda Thompson. Thompson was the first woman, or one of the first at least, in the British Empire to hold an instructor's certificate in 1933. She was the first Australian woman to fly solo from the UK to Australia in 1934. Her aviation career seems inspired by a 1926 flight in a passenger aircraft from Paris to London, about which she wrote in her diary, "Jolly fine fly, would go again if I could." And finally, Freda's achievement was also celebrated in the Melbourne Age on the 7th of December 1934. Another example of being able to draw connections between collections that wasn't previously possible through our program. So, in summary, we gave ourselves the best opportunity for success by having a clear understanding of what we were trying to achieve for our collections and our audiences, which drove our decisions. And I can sort of relate back to some of the earlier presentations on sort of starting where you are and just sort of moving forward where you can. It's also fair to say we perhaps underestimated the scope of work to move from a pilot to BAU, but we were conscious once we had proven to ourselves it was possible to deliver HTR and Trove, we needed to make it a sustainable change, and that took time and effort, so we didn't want to rush that either. This included embedding HTR as part of our digitisation workflows, while still working to streamline what we can, such as our harvesting and indexing processes. So in summary, we're excited to continue to roll out this program, and just as equally excited to see this new research tool in Trove being applied by our audiences. So thank you. Yeah.
Wow, well, thank you everyone. I can see one hand immediately going up. Have we got the mic for speakers? Brilliant, thank you, Harry. I will also give speakers a chance, because I know that I was very strict on timing, partly because we're coming up against lunch, to say if there's anything that they want to add. We'll still get everyone up. Eve, first question to you.
Thank you. Thanks a lot for the very interesting talks. I do have a very specific questions for Sophie and Stephen. Are you using the infrastructure that is provided by the European Union, the language data spaces? Is that something that you're thinking to get involved in, where the European Commission basically wants to have rights holders be able to monetize their language data? Are you... What's your take on that?
Yeah, it is something we should consider, but we're not really involved in that yet.
Any other questions? There's one over here, Jez, from Richard. And just while we're getting the microphone, okay, and Stu as well, sorry. Should we start from Eric? Is there anything that you wanted to add that you didn't get a chance to address in your...
Let me think.
Yeah, we can start.
Yeah, no, I think for, just to reiterate, for us it was, we were starting from the point of having a lot of organisational support, so that was really a driver, and this was something that there was an ambition within the organisation for a long period of time, so it feels like that innovation part was a relatively quick process for us, but it was very much started at an early point, and as we were managing our Trove ecosystem over time, particularly in the last 5 years, with those updates to that ecosystem, they were being done with the view to be able to deliver something like this within Trove for our users. So the only other final thing would just be to flag that we're very, I think for us now it's the next focus is to sort of understand how it's being applied in practice for research and our users. So we're quite excited to see that, and happy to discuss afterwards as well with people.
Awesome, thank you. Stephen and Sophie, is there anything?
Well, maybe also referring to the question, something which we find very complicated is in should we pay for licensing, or is it done then the out of commerce work into commerce again? And how does that work? So that's something we are really thinking also with our legal advisors to see how we, on the one hand, attribute to the extensive commercial extended collective licensing, which is for out-of-commerce work, but there is still some value. But if it becomes too valuable, does it undermine the whole concept? So that's a bit of the difficult squeeze we're in. So. Brilliant.
Yep. We're on the questions.
Okay.
I think we're good.
Great. Well, let's Stu, your question.
Yeah, thanks. Great presentations, everyone. Thanks for sharing. Eric, love Trove, super impressive. Can you say a little bit more about the methods for HTR? So I know it sounds like there's some volunteers, but were there other kind of automated methods that you used to scale that up?
Yeah, so in terms of the scale for us, one of the big positives was that we've got a digitalization panel of providers, so we're able to sort of use that infrastructure and Trove infrastructure itself. So that was a really positive, like a plus for us. One of the things we found to be able to sort of scale up the process is that's taken longer than probably we first appreciated. So we were very excited with ourselves to be able to sort of have that pilot and prove the concept, but it's really taken quite a lot of time to actually bed that down as a workflow, and right through to, as we're undertaking a digitalisation project, how do we scope and cost the expense of delivering HTR and Trove as well. So we're getting very close to that point now where we can actually sort of say, okay, we're going to digitise this manuscript collection with this many items, and it will cost us X amount of dollars from start to finish, and that includes a component of HTR. So yeah, the other component for us is also having that staff knowledge in terms of a workflow and a process, and being able to really bed it down into the program. Final thing is we are looking to do some more updates within the Trove ecosystem on the back end to be able to work with multiple providers as well, which I think again will help us sort of scale up the work over time. Yeah.
Awesome, thank you. We'll go to Richard, and are there any questions over here? We can get mics towards you. There's one there.
Shall I go? Yeah. Yep. Question for the Smithsonian. Do you think it would be, if in an ideal world we had benchmarks for every different type of object held in museum, library and archive collections? Because obviously against a painting versus a sculpture versus a watercolour, there's differences, and it would be useful that there was a specific benchmark for each one.
So yes and no, because I think what's also really interesting is I'd probably sped through it too quickly, but within each one of these benchmarks, you can kind of like infinitely rabbit hole to see like there's a top line accuracy number, but then within that, where does it do better? Where does it do worse? So like in creating multiple different benchmarks for different types, you might lose that comparison, but maybe combining them, you can see that, oh, I'm just thinking totally hypothetically that this vision language model does really well on sculptures, but doesn't do so well on paintings, and be able to directly compare them side by side. So yes and no, sorry. Yeah.
And I'll just add that, we do all have data which can be used without, having to do the work. Like we can use what we already have to create these benchmarks, I believe. Like we have a transcription center where we've had, years of people transcribing by hand and validating that, with people, handwritten text. And I think that might be the next project we work on, but it's there. And I think we need to take it and start using it to serve our own purposes. So.
Great, thank you. Down here.
Thank you all for very interesting talks. My question is to Eric on Trove. You mentioned on the slide that in the output it's editable, so that people can can you walk me through the process? Because I certainly hope it's not directly editable for trolls and whatever. But how do you keep that manageable if a lot of people start commenting or editing? What's happening? Could you say some more about it?
Yeah, so what we're putting online is sort of an access derivative. That's the starting point for us, and we've long had that program for 20 plus years for our OCR newspaper collection. So that idea of being able to enhance those sort of Trove view transcription has sort of been embedded with our audiences for a long period of time. So it was quite a natural progression for us to be able to sort of apply that similar approach for our manuscript collections. So that's worked quite well for us. Sorry, am I answering your question? What was the other component there? It's just in terms of the actual process, or?
Well, it's more like, is there still a middleman checking all these suggestions being done?
Yeah. Look, we have the ability to do that, but that's something that we're not going down the path of having to assess and check every update. But we do to be able to update transcription. So there is a sort of a registration process. So we would have our users go through a registration process, and we're finding that overwhelmingly there's just such a positive level of engagement with that content, and it's also coming back to that principle of if we can provide a starting point, even if that's not a perfect starting point, at least it's something that people can build upon as well. But yes, we certainly do have that practical ability to be able to go in and kind of correct or further edit where we need to.
There's a question at the back. Is that Liam? And just while we're getting going, Erin, I think it was you who showed the mods field where you had a notice about the use of AI, and also our curator of OCR, HTR, Valentina, has been trying to find out how people are noting the use of automatic text transcription tools in the metadata so that we can think about versioning. I know BNF's Gallica does that as well, but could you say something about that process or how that came about?
So this newspaper project was actually the second project that we did using this sort of approach. The first one was much smaller, it was about 2,000 images, and there was a whole team of the digitization people and the special collections people and the curators and the tech people, and it was sort of a group effort to come up with that wording because it seemed really important to do, because there's mistakes that happen all the time in this type of approach.
Yeah. I'll just ask a really boring practical question, but when you say you can contact the group, was there a contact form or email address, or how do people do that?
We're assuming that people are interacting with them through our digital collections, and there's contact information on every page.
Yeah, awesome, thank you. Liam?
Hi, yes, I'm Liam, National Gallery in University of Sheffield. So I'm talking to the Smithsonian this one, but this is a problem that I've been discussing with people all of this whole conference, and the thing that I've run into quite a lot is the issue of benchmarking, but also like leaderboarding and documenting that publicly. I'm really grateful to see that that's already being done, and it's something that I'm looking to push and move forward a bit more. But is there some way that you think that we can collect all of the different benchmarks together into one place? Is that Hugging Face? Is that something else? And yeah, what do you see for that direction for you?
I will say that I included it in the slides here, but I was like hesitant too, because I taking that on the leaderboard aspect is a lot to keep up, and I mentioned that I kind of somewhat arbitrarily chose between those two different model sets, but like, who are you leaving out when you start making a leaderboard and maintain that? And then there's the additional word of like having the Smithsonian word behind that as an implied endorsement. And so I don't think that's something we're gonna like go down that path, but like putting the data out there allows anyone else to do it. So like, yeah, maybe Hugging Face could pick that up, and then it's their thing to maintain and endorse. So just looking strongly over at Daniel. Maybe you can do that.
Great. And is it Antoine, you got a question?
Hi, Antoine from Europeana. I have a question that maybe mostly for Eric, but maybe some others are going to be have some insights to share. It's about the provenance of those enrichments, those transcriptions, because I suppose that maybe for your historical newspaper that was not so much of a strong requirement because it's more like for general audience, but for your more specific archives, is there like more of a requirement for being transparent about how the transcriptions were done, and if you have some people actually checking that, is there some disclosure more expected for those archives?
Yeah, I mean, what I would say is that there's a check and balance in even how we're presenting the content. So the digitized content is available based on the true and accurate physical holding. So that is the authoritative representation of the physical item, and the transcription is a sort of an access enhancement of that. But the actual linking the two together and presenting them together, I think provides a strong sort of check and balance in itself. I think that would be my response there in terms of, again, we're wanting that accessibility piece, but we're very much mindful that the actual digitized content is the true and accurate record, and the transcription is a sort of an additional enhancement of that. And of course, people like users can still download that digitized content, and the physical content is obviously held within our collections as well. But I think some of the conversations it does sort of prompt just in terms of the labelling of how we're presenting some of the transcriptions as well. So something for us to ponder as well.
I think there's also a kind of fascinating sector memory thing, like partly as an Australian and partly as someone who's worked on crowdsourcing a lot, I'm like, people don't know how Trove works. Like, I think it's there's that sense of, we've done a lot of these kinds of practices before. We've got lots of ways of building on the patterns, the use patterns, the transparency, how we talk to our users, and we can adapt those for what people are seeing now. But it's just really fascinating to see this kind of change, I guess, in the institutional and sector memory of how we've done things in the past. I wanted to ask Claudia about I'm really fascinated by people's really detailed prompts at the moment. Like, it's a moment of like people do share their prompts and they're like, did you say 250 lines long? And I was just wondering how many iterations you went through to get those really detailed prompts, and like the point about going to CSV and then getting better JSON I thought was fascinating.
Yeah, thanks. I think at this stage, the prompt, to be honest, is still a work in progress. I started with something and then worked my way through some handpicked examples, naively, really, going back and forth between, this is the result, this is what it looks like, this is what I want. Then slowly worked our way also to the JSON schema, which I didn't have in the beginning. So it's an iterative process. I don't know. I mean, I worked over this all summer in some way, more or less. But maybe this actually goes a little bit to the leaderboard question that Mike was. Well, we are actually trying to, we flew through this slide a little bit, but we're also trying to create this environment where you can test different prompts. So we have different prompts, you have different models, and you have different images. And so instead of, it allows you sort of to determine what is the best scenario for your specific case. So that's part of what we're aiming to do. So,
great, thank you.
Can I add on to that?
Yeah.
In terms of like developing prompts, one of the things we did at this Tackathon was to involve the librarians we were working with in demonstrating it. And one of the things we did was, try to develop a prompt to give me the OCR for this page image. And what was really fascinating was it gave us the wrong OCR. It changed the species name to a modern species name instead of the one that was printed. And it was really fascinating to show people, oh, look, we have 3 different models, and this one's giving us completely different information. And then we went back and did it again an hour later, and it gave us the right one. And I think it was a really key point to demonstrate as part of our educational component of this, to show that these things are stochastic, as somebody said. It is something that changes, and so, yes, you can focus so much on the prompt, but that doesn't guarantee the exact result each time. So, yeah.
Can I just want to, sorry. One thing that I didn't take the time to emphasize either was the critical nature of the human in the loop design that we're building. Like the whole thing about building up a JSON schema is so we can feed it into an interface where I can look at the results and verify it. Because as a curator who's presenting scientific data to researchers, I'm not going to put anything out in the world that hasn't been vetted, right? So because, right, I need to look at it with my eyes and make sure that the species name that it's sharing is the species name that's on the cards. That's a really important aspect of what we're doing.
Yeah, thank you for that. Keep the mic away. But just thank you for that point, because I think it's, people talk about human in the loop, but it's often quite abstract, and maybe that bit never gets quite built or whatever. So I love that attention to that process. I think, is it Linda, we've got a question?
Hi, so I'm Linda from the British Library, and my question's for Sophie and Stephen, please. So given that your legal deposit is voluntary, are you finding that you've got a reluctance for publishers to deposit in this AI fear environment that we're currently in?
Yes. Yes, in all the negotiations it comes up constantly, and especially with the Born Digital stuff that's coming our way, they're really reluctant to let us use it for even TDM research. So we're actually also looking at solutions like the National Library of Germany told us earlier. Yes.
We've got Owen, and then we've got Lynn. And do we have anything online, Harry?
Yeah, just a comment actually on the last question from Research Libraries UK, saying a really great talk on what a prompt. Interpretation, I think, is a real challenge, even if you build into your prompt instructions to only be verbatim and not to interpret. But definitely opportunities for a lot of heavy lifting, but with the human expert oversight and guardrails.
Thank you, Harry. Owen?
Yeah, I had a question for Erin along the same lines as Mia's question. First of all, fantastic work across the board. And also kudos for putting the information about the model in the mods record. Great. So I wanted to ask you just to say a little bit more about your thinking about what kind of metadata about the use of VLMs and in general you wanted to put in the metadata records. Like, for instance, why just the model and not also the prompt? But I realize that once you start going down that road, there's an awful lot you could include in there. So I'd like to hear any thinking you had done about that. And the same question sort of goes to the Stanford group as well, about how you're recording this information and where you're putting it and how much of it you're recording and for whom.
Just to clarify, you're asking specifically about the technical documentation sort of, yeah. The prompts, again, like I indicated, there was 3 different prompts and they were pretty long. Like, that doesn't belong in a individual record, I don't think. But we have it in the GitHub repository that has all the code. I don't know that that's actually linked from the collection. Could be an interesting thing to do. We'll have it in our institutional repository, at least the sets and probably some of the technical things used. I don't know. I just thought it was good sort of record keeping. I even impressed myself with what a good job of documentation I did for this process, like on a personal level. And so I don't think the mic's working.
I can provide a few more technical details about how we record things on the technical side. Everything just goes into a Pocket-based database for us right now. In previous projects, we've definitely made the prompts available on GitHub, and it's generally good practice, although we've had some soul searching about whether it's all that helpful for this kind of work, given that the prompt itself is well, we wanted to have a platform that would be useful with other materials, and generally you need to re-engineer the prompt when you are working with a different set of observations or anthropological record cards. So we're still kind of struggling with that question, but it's something that we're looking at. But then I don't know, Amanda, do you want to say anything more about like how would GBIF represent where this data is coming from?
Yeah, sure. So there's sort of, it's not well resolved yet, but there's sort of two endpoints for the data from this project. One would be sort of a preservation copy of all of the biodiversity data for Stanford Digital Repository, just so we can keep it safe and where we know where it is. But the end users ultimately are going to look for it in a place like GBIF. So there's a whole pipeline of work that needs to happen to transform the JSON into a Darwin Core compliant data set in GBIF. And so I imagine that we would include somewhere in the descriptive metadata information about how we did ultimately decide on which model and which prompt and so on. But at the record level or the data set level, it seems like we just would tie back to the description for the data set as a whole. I mean, I think the transparency is a critically important goal, but maybe we're still working out how to get there.
Hi, is this working? Yeah. I'm just dying to get a tip out to you guys because it's killing me. The prompt optimization problem. There's actually a couple of methods you can use to optimize prompts automatically using LLMs to help you get to a good prompt. And I would highly suggest doing them because you can use cheap models to get you to a good prompt that works for your use case with test cases. So it's exactly like a benchmark for prompt development so that you don't have to do this endless guessing about what's going to work. So DSPY is the primary library from Stanford that you want to look for this, but there are a couple of other libraries that will also help you. Because of DSPY's popularity in this helping you get the prompt to work for your use cases, a couple of other optimizers have come around. The other tip is some models will now do structured JSON output as part of the schema that you give it. And so you don't have to do this like go to CSV. I know because I went through that route too. So the Gemini models, you can give it a Pi class that tells you exactly the fields you want for your structured output, and it will adhere to that when it returns you the results with the types and everything. So absolutely, like stop trying to parse you don't have to parse your JSON manually and validate it yourself anymore necessarily, depending on the model.
I think that's the best comment as a question that I've ever heard. Thank you, Lynn.
Can I respond to that?
Yeah.
Oh, well, is this working again? Oh, it is. Okay. Yeah. One, because I did look into the prompt optimization. I just wanted to respond to it, but it kind of breaks down when you're trying to compare 9 different models because you come up with a prompt that is like fine-tuned for that model, and then do you do that individual step for each model? It gets out of hand. But there's also, to follow on the structured output. Also, we did use that exact one for the Gemini, but then for the open source models, there's another project called Outlines that will actually like force the output directly into JSON out. So it's no prompting or anything. It just like looks at the output and rejects it if it doesn't follow the prompt, and it makes it go in there. Yeah. Great.
Awesome. We've got Björn with a question.
Oh, can I just say real quick too that I also just built in a little loop when I got the response, tested against the schema that was already there, and if it failed, then just ask the model again, and it would usually get it the second time.
Yeah, so I'm Bjarne from the Royal Danish Library, and my question actually goes in that same area for the panel, or maybe even for the audience. So we've, during yesterday and today, heard a lot about prompting, engineering, struggling efforts, etc. So where and how do we share best practices for all of this? Can we as a community build some kind of prompting library, best practice, wiki style, I don't know, whatever? So yeah, maybe a comment for common discussion in the coffee break or during lunch.
I'm also looking at Inez for this as well, thinking about AI for LAM as a community and how we share resources. And there's the Slack, there's the Google group, so there are places where people can gather, but maybe thinking consciously about what kinds of prompts we want to give people to share specific assets at the moment, given the common difficulties that we're hearing people are facing.
I'll start off, not that I know everything about this, but I see like there's two separate questions there. One is for, the real practitioners here who need to understand the scientific prompt necessity. But I think there's a real value in studying how general users are using these tools because, especially library side of LAMs, we're going to be helping people with this. And so I think there's studying how people naturally are interacting with these, chatbots that we need to study and understand and thoroughly, get to so that we can kind of maybe help them along to say, to show them what's good and what's bad and things like that. But I think there is a larger, question of the scientific kind of precision of prompt engineering that somebody else can talk about.
We've got time for probably one more question. Is there anything? Yeah. Harry will bring you.
Thank you very much, Mia, for mentioning working groups and chapters that we are delivering at AI for LAM. And maybe not a question more than I would say invitation, is that all of you that are delivering, developing, researching, thinking, questioning different aspects of AI tools and services in our internal and also external use of institutions, I would invite you all to join the already existing working groups, speech-to-text, metadata creation, etc., also educational working group that is led by Claudia there on the stage. But not only that, that you also a bit think what we need. For example, like we could have a working group on prompts, if that's a case today. So to think about what we need and propose us to build the new working groups and new areas that are important for all of the, I'll say, cross-sectoral collaboration in AI for LAMs. So thank you very much, Mia.
Yeah, no, thank you. And I think there is actually an evaluation working group as well. So yeah, do check out the AI for LAM Slack. Are there any other questions before we go to lunch? Is everyone just dying? Okay. I would just like to say, because we know that people have been asking, and to thank particularly the live transcribers who are actual humans. And yeah. And of course the AV team, but also to all the speakers who shared their slides in advance, which enabled the transcribers to know the names, the jargon, things like the model names that we're mentioning, the names of their collaborators and speakers. So thank you all the presenters for making that easy for the transcribers and for the organisers as well. And I would just like to invite you to visit the poster session in lunch. Yesterday it was so busy, there were so many brilliant posters, and we've got a whole new set today. If you are a poster presenter, you can nip into the Chaucer room just behind here and grab some lunch early so you can be at your poster station by the time people come in to see you. But just please join me in thanking this brilliant section of short speakers.